You are most welcome to one of our episodes in trigonometry, a topic taught in A-level principal mathematics. My names and contacts are shared on your screen. You can visit them. That contact also is on WhatsApp. In case you want any other extra help, you can contact that telephone number. And you can also visit and subscribe. Please subscribe to our channel, support the work we are doing, and also be able to visit our WhatsApp. We have a WhatsApp group where students discuss and come out with solutions to mathematics problems. We are always there guiding I and some other team of teachers. Wonderful. Now, in today's episode, we are looking at the form A cos theta plus or minus B sin theta. A and B are constants, not necessarily rational constants. They can be even surds. And so it might be 3 sin theta minus 4 cos theta. It might be 12 cos theta plus maybe 5 sin theta. It might be sin theta minus root 3 cos theta. And this theta might even be a 3 theta. So any equations of this format is what we are dealing with today. What is the key is that we should only have sine and cos in our expression, no tan, no sec, no cot, no cosec. Secondly, the angles must be the same in the expression. If it is theta, it is a theta. If it is 3 theta, it is 3 theta. They don't have to be mixed. And the terms should only be 2. That is where we apply this form and we get for it a general solution as we are seeing here. That you can express this expression here in terms of r sine theta plus or minus alpha or r cos theta plus or minus alpha. Sometimes in most cases we are guided, but in other cases the learner can figure it out himself. Let's see if I have an example. For example, if I have 4 sin theta plus 3 cos theta. Now look at this one. Here, if I look at this expression, first of all, I think in terms of our addition formulae, if you can remember them. If you don't remember, you can pause this video here, go back to the home page of this channel, look for that particular episode, that video we made on addition formulae, and visit it. But among our 4 addition formulae, we had the major ones of cos and sine. There were only 2 which had a plus in the middle, and these were cos of a minus b and cos of a sine of a plus b. It is these 2 that gave us a sum when opened that had here it gave us cos a cos b plus sin a sin b. Here we had the sin a cos b plus, you to call that one. Now we want to channel or to transform this expression also appear like that. However, we have a 4 here, we have a 3 here. And the cos and sine of any angle is always at most positive 1, minimum negative 1. Now, since we have a 4 and a 3, we shall assume that our sine of some angle has been multiplied by a certain number, certain digit, certain rational constant or irrational constant to give us a 4. In other words, it is okay for me if you want this to be in terms of sine theta plus something, then this should be r cos of alpha, and this should be r sine of alpha. So that you can have r sine theta cos alpha plus r cos theta sine alpha. Now, if you have this one, you can easily say r sine into theta plus alpha. If you pull out the r, that is one case. The other case scenario is if we want to make it in terms of cos. Now, for cos, this one should be a sine here also, sine alpha. But since we have a 4, we look for a constant which, when we multiply it by, we want to use a sine, by r sine alpha, it gives us a 4. Here we look for r cos alpha to give us a 3. So what we have, r, open brackets, now I'm replacing 4 with this, r, here we shall have sine theta sine alpha plus cos theta cos alpha. Now, if you recall from addition formulae, that one in the brackets is the same as r cos of theta minus alpha. So that's what we are trying to look at. We are trying to master, but we shan't, of course, be using guesswork as what I'm doing here. I'm doing it out of experience, but we shall be looking for a way of expressing this general expression in terms of r sine theta plus something minus something, r cos blah blah blah. R is a positive constant and alpha is strictly an acute angle. As I have just talked about, the highest value sine and cos can assume is positive 1, and the lowest value sine and or cos can assume is negative 1. That is very important. I shall be applying it along the way. So we can use this kind of expression to solve equations of this form. There are some equations we solved before using the T formulae. Now, those very equations that we did using the T formulae, we can now solve them using this expression, this what most people prefer calling the harmonic form. Math is doing. You don't have to waste so much energy explaining in words. Math is best learned by doing. Let us move on and do some examples that will help us to assimilate or to understand what we have just talked about. Question number 1. They are saying express 4 cos theta, express 4 cos theta minus 5 sin theta in the form. Why am I using those symbols? Those are equivalence signs. We can only use equal signs if we have established the value of r and the value of beta. So r cos theta plus beta. As it is commonly done, we are always given what to assume or what to use, unless maybe you're trying to solve an equation and you decide to use this form. But generally, you can actually use what is given to us. So r, now I'm going to open this bracket. Please, I'm using the equivalent signs here. If you put here equal signs, you have messed, unless you are, these two things are just equivalent, not equal. So I'm using equivalent signs. But now here I'm using equal sign, meaning that this step is equal to the right hand side there. Now we're going to use our we're going to use our addition formula to expand this. It will be cos theta cos beta minus sin theta sin beta. When we open that bracket, we get r cos theta cos beta minus r sin theta sin beta. Now we can compare the sides. We have left hand side and we have the right hand side. We can say equate coefficients of cos theta, because here you have cos theta, here you also have cos theta. So you'll have r, the cos of beta is equal to 4. Call this equation 1. Again, we equate coefficients of sin theta, because here you have sin theta, here you also have sin theta. So you'll have 5 is equal to, here you have a 5, here I'm just dropping the negative because they are here on both sides. Here you have 5, here you have r sin beta. Call this equation number 2. Now we shall play with these two equations, 1 and 2, to get the value of r and the value of beta. How do we get the value of r? What if we square from our first lesson of trigonometry? Since these ones are all having r as the coefficient, if we square the two and factorize out and then add them, then factorize out the r squared, we get something which can reduce to 1. So equation 1 squared plus equation 2 squared. If I square this, I will get r squared cos squared beta. On the left, I'm adding there r squared sin squared beta is equal to 4 squared, which is 16, plus 5 squared, which is 25. I can pull out my r squared, which means r squared is equal to 41. What is in bracket here is a 1. Which means my r is root 41. Remember, the root of a number is a plus or a minus, but strictly for this kind of expression, we are taking r to be a positive constant. Now we have got that one. Let's try to find the value of theta of beta. For beta, you have 1 and in equation 1 and 2. We can see that we can easily get tan by dividing equation 2 by equation 1. Alternatively, you can just pick your r, root of 41, you put where r is, you get beta using cosine. And it can work. Feel free to be a good explorer. So we're going to divide equation 2 by equation 1. Equation 2 divided by equation 1. If we do so, we shall get r sin beta over r cos beta is equal to r sin beta over r cos beta is 5 out of 4. R goes with R, you get tan beta is 5 out of 4. So our beta is tan inverse of 5 out of 4. Using your calculator, it will give you 51.3 degrees. Therefore, we have now got our final expression. The whole thing which they were asking us to express, which was 4 cos theta minus 5 sin theta, 4 cos theta minus 5 sin theta is root of 41 cos of theta plus 51.3 degrees. That's our desired expression. Now, this question had another part, and the part was saying, determine the maximum value of the expression and the value of theta for which it occurs. Part A, determine the maximum value of the expression and the value of theta for which it occurs. What is the expression? It is here. It is what they want us to find the maximum for. Now we are replacing this value, this function expression with what we have just got. So 4 cos theta minus 5 sin theta maximum is the same as root 41 cos theta plus 51.3 degrees maximum. Now, since root 41 is a constant, that one is out. And the maximum of cosine, because for you to get a maximum out of the product, both things must be maximum. 1 trillion times 1 trillion is a very big number. So they must all be very big for you to get a maximum. So since this one is not changing at all, the size of the whole expression depends on cosine. So for it to be maximum, this cos must be a maximum. And the highest value of cosine is positive 1. So the maximum value of that expression is the square root of 41. The value of theta for which this occurs, and we have already seen it, we have said, for it to be a maximum, this value of course should be 1. So we put it to 1. So value for which maximum occurs, value for which maximum occurs, value of theta for which the maximum occurs, shall say cos of theta plus 51.3 degrees should give us positive 1. That is the maximum value, which means theta plus 51.3 degrees is the cos inverse of 1. Theta plus 51.3 degrees is equal to cos inverse of 1 is 0. Cos inverse of 1 is 0. And where else is cos? Because if cos inverse of 1 is 0 degrees, we need to find another value which gives us the same. So the other value of cos inverse which has a positive, it is in the fourth quadrant. And in the fourth quadrant, cos is positive, and the angle here is given by 360 minus theta. so minus the acute angle. So the acute angle here is 0. So 360 minus 0, you get 360. So we want to find the value of theta now. Theta is equal to 0 minus that one, we get negative 51.3 degrees. Then 360 minus 51.3, we get 308.7. So those are the values of theta for which the whole expression is a maximum. Next, we are going to look at a question still had some other parts. Part B was saying, solve the equation 4 cos theta minus 5 sin theta is equal to 2.2. Remember, I've already got the expression for 4 cos theta minus 5 sin theta. So we shall just replace that function there with what we have got. So we are replacing 4 cos theta minus 5 sin theta with the root 41 cos of theta plus 51.3 degrees and is now equal to 2.2. So let's solve. So cos of theta plus 51.3 degrees is equal to 2.2 out of root 41, which means theta plus 51.3 degrees is the cos inverse of 2.2 out of root of 41. Now here we have to be very careful because the theta that is being asked of us to find, it is given a range from 0 degrees to 360 degrees here. That is the range given to us. But now, after getting our beta, which we have found to be 51.3. Now, the inverse we are now trying to find, the cosine inverse we are now trying to find has been edited by adding there 51.3 here. So if it was theta only, it would be between 0 and 360. But now there is a plus 1.3, which means we shall add this value on the lower limit and the upper limit. Lower limit was 0. Now it will be 51.3 theta plus 51.3 to 360 plus 51.3, which will be 400, I think, and 11, 411.3. That is now our new range. So we must get angles in that range. We can't get an angle below 51.3. We can't get an angle above 411.3. If we don't do this amendment, we shall end up dropping some solutions at the end of the day. So always be very observant and keen with it. So let's see. In the first quadrant, cos is positive. So cos inverse of that one gives us 69.9. 69.9 degrees. Now in the fourth quadrant, also cos is positive. It will be 360 minus 69.9, which gives us 290.1. Since our cycle goes above 360, the range, we are going to get another angle here if possible. Which angle is that? It will be 360 plus the first angle, because to go for other cycles, other rounds, we always say 360n plus the angles we got. So 360n, our n is number of cycles. So here we are in n equal to 0. Now for n equal to 1, it means we shall say 360 plus these angles we have got. So 360 plus 69.9, we get something in 430 something, which is above our upper limit. So in this case, we ignore the next angles and we stop there. So therefore, the theta they're asking us to find, we shall be saying this angle take away 51.3 as it goes to the right hand side. So we shall get 18.6 degrees and 238.8 degrees. Got by subtracting 69.9 divided minus 51.3, you get 18.6. 290.1 degrees take away 51.3, you get 238.8 degrees. That was question number 1. Allow me go to question number 2. Question number 2 says, express 8 cos x plus 6 sin x in the form r sine. This time they have given us what we're supposed to use in form of r sine x plus alpha, where r is positive and alpha is acute. Hence, find the maximum and minimum values of the given expression. So we start by letting our 8 cos x plus 6 sin x to be equivalent to, not equal, equivalent to r sine x plus alpha. We open the brackets. It will be r. Don't ask me why have you used here equal signs. Now this second step is equal to the first one, not the left. The left is equivalent to the right. So r sine x. People who didn't go through our video, or who didn't study relation formulae, will now be seeing stars here. Cos x sin alpha. Then we open the brackets, r cos alpha sin x. We have r sin alpha cos x. Now we can compare coefficients. Compare coefficients of cos x. Because here we have cos x, here we have cos x. So the coefficients are r sin alpha is equal to 8. Equation 1. Then compare coefficients of sin x. This will be r cos alpha. That is the coefficient of sin x here. Then on the left we have 6. Call this equation number 2. Now I shall play with these two expressions to get the value of r and the value of alpha. Divide equation 1 by equation 2. Equation 1 divided by equation 2. It will be r sin alpha over r cos alpha is equal to 8 over 6. Is equal to 8 over 6, which means tan alpha is 4 out of 3. So alpha becomes tan inverse of 4 over 3. We are only stopping at acute angles, so don't go to look for tan, to look for whatever tan is positive. So tan inverse 4 out of 3 gives us 53.1. Please always make sure that your calculator is in degrees when dealing with this kind of thing. Now, we have got the value of alpha. It is okay to substitute sometimes this value you have got into one of the equations, but me, I don't believe in that so much because the angle I've got there has some rounding. So I prefer that we always do these things in the original form. So I prefer that we actually go back, square those two equations and add them. So square equation 1 and add there the square of equation 2. So it will be r squared sin squared alpha plus r squared cos squared alpha will be 8 squared, which is 64, plus 6 squared, which is 36. So we'll have r squared is equal to 100 and our r is equal to 10. Therefore, what we had now can be reduced to something very small. Now 8 cos x plus 6 sin x is equal to 10 sin x plus that. So therefore, we have now found we are free now to use the equal signs. We can now say that 8 cos x, 8 cos x plus 6 sin x is 10 sin of x, because now our r is 10, x plus 53.1 degrees. Now we have finished that expression. Then they were saying we are supposed to hence find the minimum and the maximum of, yeah, we are now on the hence part. Find the minimum. We want to find the minimum of what? 1 plus 8 cos x plus 6 sin x plus 15 minimum. If you want to find the minimum, I can now easily replace 8 cos x plus 6 sin x with what I have got, with 10 sin x plus 53.1 degrees plus 15. Now this whole thing, I'm supposed to find a minimum. Now here you are supposed to be very comfortable with especially the knowledge of errors that you studied. Errors in division, maximum error, all that. Now, look at this expression. For me, if I'm dividing two things to get a minimum, if you have some oranges, you want to give them to some students. For them to get very little, you have to get something very little and divide it by many. So if you get like 20 mangoes and divide among 80 pupils, it means each person will get a quarter of a mango, very small share, which is the minimum. But if you want something big, I get very many things, 80, I divide among 4 students. Each gets his 20 mangoes. So when you divide something by anything by something very big, you get a minimum. So in this case, our one is fixed. For me to get a minimum out of dividing one by something, I must divide one by something very big. And for something to be very big and you are adding, then the things you are adding must also be very big. So even this one must be a maximum. So it will be 1 out of the maximum of this, which is 10 times 1, then plus 15. 15 doesn't change. You get 1 out of 25. That is the minimum. Then, what about the maximum? What about the maximum? Excuse me. What about you want to now use the same? Oh, dear. Excuse me. Excuse me. Where? Here. What about the maximum of this? Now, for this thing to be a maximum, again, we have pressed here. Now, for this, as we have said, to be a maximum, you are supposed to divide something by amongst very small or very few. So, it means down here, supposed to have as small as possible of a denominator. And for this to be as small as possible, then the things you are adding should be as small as possible. Since 15 is fixed, it cannot change. Then whatever you are adding 15 must be very small for the whole sum to remain small. So I'm looking for the minimum of this. And the 10 times what? The lowest value of sign is -1. So I get 1 out of 10 times -1 plus 15. And I get the answer as 1 out of 5. So our lowest value was 1 over 25. Now our biggest value is 1 out of 5. And indeed, fractions. 1 over 25 is smaller than 1 out of 5. Let's now go to the last question. Number 3. Here we are. Now this time, they didn't give us any hint of what to use. But they are saying if 3 cos theta minus 4 sin theta minus 2 is equal to 0, find all the values of theta which lie in the range 0 degrees and 360 degrees. Now, this one you can do it using T formulae, which we saw in the previous videos. But now I want specifically to use this form of R cos or R sin. Whatever you will choose to use is what I will use also. Now, here we have this can be in the form of 3 cos theta minus 4 sin theta is equal to 2. That is one way of doing it. whereby since I'm beginning with the cos this side, cos should be the cos of a plus somewhere in addition formula. Because it is theta plus the angle we want to find, not the angle we want to find plus theta. It is theta plus the angle we want to find. So this can't be sine. If you want to make it sine, it will be, you will take these ones the other side, and you have 4 sine theta minus 3 cos theta is equal to -2. If you do it this way, you also get the answer. But here you are free to use r sine theta minus alpha. Here we will use r cos theta plus alpha. Then you proceed to get r, you proceed to get r, you get alpha, you get alpha. I'm going to use the first one because I don't like using negative values. But if you are good with it, or you can use your -2. So let us let 3 cos theta minus 4 sin theta to be equivalent to r cos of theta plus beta. Use beta is more beautiful than alpha. Now let's open the brackets. I believe by now all of us can reach this stage. If you cannot reach this stage, pause the video, rewind, and go back to the previous examples 2 and 1. Now compare coefficients of cos theta. So I will have r, the cos of beta here, is equal to 3, or this equation 1. Again, please make sure that you're working looks like an essay. Even the one who is scoring your work should be looking at work which flows. Coherence is very important. Don't just be throwing things. You think from your head, just with other cos beta is equal to 3. They should see where it is coming from. Oh my God. Excuse me, there is something here that has happened. My work has misbehaved. Let me bring it back. Good. It's back. So here we got r. Sorry for that. Sometimes technology, there is a way it bullies us. We had r sin beta being equal to 4. Sometimes we can be bullied by technology. Okay, now we can find the value of r and find the value of beta. Since I've already done 2 examples on this, I'm leaving it to you as a challenge to move from here and show us that our r is 5 and our beta is 53.1 degrees. And I'm leaving it to us as our challenge. Now, what does this mean? It means my Therefore, my 3 cos theta minus 4 sin theta is 5, as you have done it here, r cos theta plus beta. So if r is 5 and beta is 3.1. So cos theta plus 53.1 degrees. Now I'm going to use equal signs because I have found the value of r, I have found the value of beta. But from how we had simplified, this expression on the left was the same as 2. So therefore, 5 cos theta plus 53.1 degrees is equal to 2. Is 2 or 2.2? As if it was 2.2. Check. It was 2. It was 2, not 2.2. Is equal to 2. So therefore, cos of theta plus 53.1 degrees is equal to 2 out of 5. Theta plus 53.1 degrees is the cos inverse of 2 out of 5. So cos inverse of 2 out of 5. If you have your calculator there, very fast you can get for us the answer. Second function, cosine of 2 out of 5. Mine is giving me the answer as 66.4 degrees. That is the acute angle. Again, remember, we have edited our range. Here it is from, theta was from 0 to 360, which means the range for the whole of this will be starting from 53.1 and ending at 360 plus this. So we are adding this acute angle on both limits. So cos is positive in the first and in the fourth. Now in the fourth, it is 360 minus this. 360 minus 66.4, giving us 293.6 degrees. That is an angle in the fourth quadrant. Let's see the fifth. Does it make sense? Because 360 plus this is 413.1. Let me see if I add this and to 360 going for another round. Is it still fitting in our budget, in our range? So 360 plus 53.1 is 413.1. 413.1 is the highest we can go. So what is 360 plus 66.4? We get 426.4. So we can't go for another round. We stop there. So therefore, the theta that we are asked to find is these angles take away 53.1. So 66.4 take away 53.1. You get 13.3 degrees. Then 293.6 take away 60, take away 53.1. 53.1. We get 240.5 degrees. So those are the two angles between the range of 0 degrees and 360 that satisfy our equation that we began with in the first place. We are almost finishing the topic of trigonometry. We are left with not more than, I think, 4 to 5 episodes, because we need to exploit inverse functions, we need to exploit general equations. Also, we shall have a special treatment for them, the ones that we haven't catered for under the T formulae and this harmonic form. Then we shall go to the major one, which is the major part of further trigonometry, which is the solution of a triangle. So keep tuned, subscribe, please subscribe, give us a like, please give us some comments. Let us keep the project moving. Thank you.